Watch what happens when I throw the ball and hit the wall. If I hit the wall with the ball, the motion of the ball is an accelerated motion. It changes its direction as it rebounds off of the wall. Now, when we see accelerated motion, we have to have something exerting a force on the ball. And the thing that's exerting a force on the ball is the wall. The wall exerts a force on the ball, and if the wall exerts a force on the ball, Newton's third law says, the ball exerts a force on the wall. Well, that's the way that we create pressure. Molecules, like little balls, are bouncing off of the wall, 1, 2, 3, like that. And as they do that, they exert a force on the wall. And the sum total of all of those forces from individual molecules is the pressure, the force per unit area that's exerted on the wall. This little machine can kind of illustrate that origin of pressure in molecular collisions. Down in here, there are a bunch of tiny little nylon BBs, and there's a motor down in the housing here. In a moment, I'm going to turn on the motor. The motor is going to make a little paddle go round and round, and as it does, it's going to kick into motion those little BBs. And as those BBs now are moving and collide with the little paddle on top of them, they're going to exert pressure. Now, the faster the molecules are going when they rebound, we would expect the greater the pressure. The faster they're going, the greater is their average kinetic energy. But temperature is a measure of average kinetic energy. Consequently, as we make them go faster by turning up the speed of the motor, it's very much like increasing the temperature of the gas. As we increase the temperature of the gas, we expect it to exert a greater pressure. So, let's see if we can turn it on and begin to exert pressure. I turn down the temperature, slow down the motor, then it exerts less pressure. But if I heat up the gas, that is, increase the kinetic energy of the molecules, they exert a greater pressure.